In this video, we are going to be talking about surds in mathematics. Now, this is also quite one of the few basic topics in math you encounter, especially if you're writing exams like JAMB, WAEC, or O-level exams in general. It is also one of the important aspects of mathematics you need to know in order for you to be able to tackle problems on every other topic in math, just like indices and logarithm. Okay, we're first going to start with the laws of sorts, and then we're going to solve JAMB questions and WAEC questions relating to this topic as well. So let's start with the laws of sorts. Okay, now there are quite a few numbers of laws, okay, and the first few ones are the most important ones, so we might not even write the remaining parts of the laws, okay, since it is just the basic 2 to 5 laws that are important in solving problems of sorts. Okay, we're going to start with the first one. Now the first law of sort is given as the square root of a, okay, times the square root of b. Now, first things first, how do you know if a problem is relating to surd? Okay, it has to do with square root. Okay, whenever we are having numbers that are not perfect squares, but they can be reduced in such a way that we can write them as a whole number and the root of another number, we take them down to what now? Surds. Okay, and the laws of surds can be applied. Now, if we are having the square root of a number, for example a, multiplying the square root of another number b, how then are we going to solve a problem like this? The square root of a times the square root of b is equal to the square root of a times b, which means we are going to pick one root since they are multiplying each other, and then we are going to multiply what is inside of the root. Here is an example. Let's say we are having the square root of 3 times the square root of 9. Okay, since we are having the same square root and they are multiplying each other, we can pick one and then we're going to multiply the numbers inside. So this becomes what? 3 times 9. And this is square root of 3 times 9 is 27. And then we'll have there 27. Okay, here is another one, law 2. How about when we are having division? For division, the square root of a divided by the square root of b is equal to, we're also going to pick a single square root and then we divide what is inside. Now, why dividing? We are dividing the first number by the second one. Okay, so this is not b divided by a, but rather a divided by b. Similarly, we can come here and we're going to have, for example, square root of 9 divided by the square root of 3. That gives us the square root of 9 divided by 3, which can be simplified further to the square root of 9 divided by 3, that is 3. Okay, now if you can simplify it further, you do that, but if you can't, you can leave it that way. There is no issue with that. Okay, now let's take lot 3. For lot 3, we are going to be multiplying a number by the square root of another number. So let's say we are having a times the square root of b. Let's say we're having something like this. What then are we going to do? You can just multiply them directly, okay, and the a comes in front. So this is now called a root b. Okay, it is called what now? A times root b is now what now? A root b. That is a times the square root of b. So if you see a times the square root of b, it simply means what now? A times root b. Now please take note, this is different from the 8 roots of b. If the a is inside of the square root, it is different from when it is outside. Okay, a root b means a is multiplying b, and a inside of the square root, root b, okay, means we are trying to find the 8th root of b. That is like saying the 3rd root of what now? B, or the 4th root of b. It is different from when we're having 4 root b. Okay, these two things are not the same. 4 root b means 4 times this, and this one means the 4th root of what now? B. That is what number do you multiply by itself 4 times to give you b. If you don't understand that aspect, you might want to watch our video on indices to get a good understanding of that. Okay, now for law 4, if we're having the square root of a multiplying the square root of a, now here you notice that this one is similar to law 1. The only difference is that we are multiplying the same number. We are multiplying the number by itself. So square root of a times the square root of a, what then are you going to get? Now for the laws of sorts, we simply go straight to pick one of the numbers inside of the square root. So square root of a times square root of a is simply equal to what? A. Okay, now here is the proof. If we have the square root of a times the square root of a, we can apply the first law, pick one root and multiply what is inside, right? So we're going to have square root of a times a, which is the square root of a squared. Okay, now from our laws of indices, squared can cancel as what now? Square. So I'm left with a, which means rather than going through this process while solving, which will save your time, especially if you're writing an exam, it will be easier to just pick the number inside of the square root after multiplying. So the square root of a times the square root of a is simply equal to what now? A. Now, we talked about multiplication and division. For law 5 and 6, we are going to be writing the law in quite a different manner, such that we're going to be using plus and what now? Minus. So let's say we're having the square root of a plus the square root of b. Now take note. In the laws of Surds, we cannot add these two things together. Okay, that is, we cannot pick a square root and add what is inside. So I'm going to say the square root of a plus the square root of b is not equal to the square root of a plus b. It is not equal to. So if we're having, for example, root 3 plus root 5, we cannot say it is equal to 3 plus 5 equal to square root of 8. No, it doesn't work. Okay, it only works for multiplication and division, but for addition, its work now doesn't work. You can confirm by using a calculator. Pick any number, solve for this directly, and then solve for this directly. You get totally different answers. Okay, now let's talk about law 6. For law 6, I'm going to replace this one with a negative sign. So I'm going to have the square root of a minus the square root of b. What is this then going to give us? It is going to give us, it is not going to be equal to, rather not going to be equal to the square root of a minus the square root of b. Okay, it is not going to be equal to this guy. So the law doesn't hold for addition and subtraction, but it works for what now? Multiplication and division. Okay, so those are the basic laws we have in Surds 1 down to 4, and then I said 5 to 6 could be added if you needed to. Okay, now we're also going to be talking about something very, very important in Surds. Okay, now in the math world, what we hate as mathematicians is to leave the square root of numbers at the bottom of a fraction. That is, we don't want to have fractions as denominators. We don't want to have roots or surds as denominators. Okay, what I'm trying to say is, anytime we're having something like 1 over root 5, we don't want to leave an answer like this. We don't always want to leave the square root of a number in the denominator. Okay, now how then do we remove these guys from the denominator? There is what we call in Surds rationalization. Okay, rationalization simply means removing the square root of a number from the denominator. Okay, so whenever we are having the root of a number as the denominator in a fraction, what we do is what now? We rationalize. And by rationalizing, there are different ways to do that. Okay, so I'm going to come here and talk about the rationalization of Surds. Okay, there are different ways to do it. Now, to rationalize a system like this, okay, I'm going to write different systems, and I'll tell you how to rationalize them. Now, you don't have to cram these things. What you do is solve practice questions on this, of which we are going to be doing after this video, okay, or after I explain these laws rather. Solve practice questions with it, and then you get used to it. Okay, you know what to do at every point in time. So let's say we're having, for example, 1 over the square root of a number, let's say a. Now take note, we cannot leave the surd in the denominator. If it was on top, no problem, but since it is under, we have to remove it. Okay, we don't just want it to be at the bottom. Now to rationalize this, what we are going to do, we are going to multiply by the denominator. But why do we multiply the denominator? Why don't we multiply by the numerator? Simply because we've noticed that when multiply by the numerator, we still get the same thing, or we get a different expressions entirely, and it still can't be rationalized. Okay, because the source is going to remain the denominator. Okay, but if we multiply by the denominator, it means we're applying law 4, and we'll multiply with a by another root a. We're going to get a. So if I multiply this bottom by root a, it is going to turn into a, which means I've succeeded in eliminating the square root of a from the bottom. What I'm going to do, I'm going to multiply the top square root of a divided by the square root of a. Take note, we're not only multiplying the bottom. If you're multiplying the bottom, you have to multiply the top, simply because this guy can cancel out this guy and we're having the same thing. Okay, so 1 times the square root of a is 1 root a. Applying this law. Okay, law 3, a times root b, what now? 1 root b. Okay, now 1 times square root of a is 1 root a, and 1 root a is what now? Root a, simply because 1 multiplying anything is that thing. So this will be equal to the square root of a divided by square root of a times square root of a is simply equal to what now? a. So that is how we work now, rationalize when we're having cases like this. Okay, example, 1 over root 5, we're going to multiply the top by root 5 divided by root 5. So that is equal to root 5 over 5. That is how it is being done. Okay, now let's talk about the next case. Okay, let's say we are having a case like this. 1 over, now any number or even a sort could be in the numerator, anything could be in the numerator. Okay, I just do not want to start putting numbers. Okay, so even if there's a 2 here, there's a 1 here, there's a 5, there's square root of 9, as far as it's in the top, it doesn't change anything. Okay, so let's say in this case we're having something like the square root of a minus the square root of b. Okay, let's just say plus or minus. Okay, so don't start doing a whole lot of calculations. So would it be easier that way? Okay, let's start with 1. Let's just say plus. Now if we're having a case like this, 1 divided by 2 surds that are adding each other. Take note, we're not going to multiply the top and bottom by root a plus root b. No, it doesn't work. Simply because if we do that, we are still not going to convert the whole denominator into numbers that are not carrying square roots. Okay, what we do, we throw our mind back to what we call the difference of two squares. Now for difference of two squares, here is what it is saying. Whenever we are having two squares subtracting each other, that is a squared minus b squared. Difference means subtraction. Okay, the square is a squared and then b squared. Okay, whenever we are having two squares subtracting each other, we are going to add the two numbers and multiply it by subtracting the two numbers. Take note, so this is the first one minus the second one. Don't go and write b minus a. Okay, so that is the law. And then we'll notice that if we apply the same thing here by multiplying this guy by itself, we are going to square each of the surd and square cancels out the roots. Let me show you. So for this guy, we are going to multiply by what we call the conjugates. I'm going to write it here. Conjugates. Okay, whenever you are rationalizing surds like this in general, what you do is you multiply the top and bottom by the conjugate of the denominator. Take note, we are going to multiply top and bottom by what called conjugate of what denominator. Now what is a conjugate? If we're having the square root of a plus the square root of b, the conjugate of that of square root of a plus square root of b is simply replacing this plus with a minus. So what is the conjugate of square root of a plus square root of b? Square root of a minus square root of b. What is the conjugate of square root of a minus square root of b? The conjugate now becomes what now? Square root of a plus the square root of b. So for conjugate, if it is plus, put minus. If it is minus, put plus. That is how it is being what now? Done. So what is the conjugate of this guy is what the conjugate of this guy is what we are going to use to multiply the top and bottom. So when we do that, so we are going to have the square root of a minus the square root of b divided by the square root of a minus the square root of b. Okay, we are simply doing this because we want to rationalize. Now 1 times the numerator, it remains the same. We have square root of a minus square root of b divided by, now look at this bottom, we are going to multiply. We are going to have square root of a plus square root of b times square root of a minus square root of b. Okay, so at the top we are going to have square root of a minus square root of b divided by, now look at the bottom. Trace your mind to the difference of two squares I explained initially. A squared minus b squared is this guy. Okay, so we're having a plus b times a minus b. Here we're having with a plus root b times with a minus root b. It doesn't matter if anything follows it, as far as we're having this format in our calculation. Okay, we can simply go to the left hand side. That is, we are going to pick the, we'll go to the negative side of the multiplication. Okay, we are going to pick the first number, square it, pick the second number, square root, and we'll subtract them, which means in this case at the bottom we are going to pick the negative side, that is square root of a. Square root of a, there's a square there, so I'm going to square it, minus square root of b, there's also a square there, so I'm going to square it. Okay, now that simplifies to the numerator remains the same with a minus with b divided by square cancel square root, so I left what now? A minus square cancel square root, so I left with b. Now what you notice is that there is no longer a surd in the denominator. We're no longer having a surd in the denominator. Okay, we've succeeded in removing the square root. Now if I should punch this whole stuff on a calculator directly, I'll get the same thing as if I do this. Okay, it's just math. Okay, we just decide to not leave any surd in the denominator. So when having cases like this is how we do it. Okay, so you have to create a way or look for a way in such a way that when you multiply, or rather when you're having a surd in the denominator, you multiply by something that helps to what now? Remove it from the square root of the denominator. Okay, now let's say we're having, for example, 1 divided by the square root of a plus b. How then are we going to do something like this? Remember, we don't want to leave it. Okay, we don't want to leave our answer like this because of the surd in the denominator. How then are we going to multiply? You might want to pause the video to think about it Okay, pause the video and think about it, or you can take your pen and do some maths to see how you can remove this from the bottom. Okay, pause the video and think about it. Now I'll assume we've done that. Okay, how then are we going to eliminate these roots from the denominator? Now in this case, we don't have to multiply by the conjugates, because if I choose to multiply by the square root of a minus b, it will be impossible to remove it, simply because when I pick one square root, okay, after doing it, a plus b times a minus b will lead me down to a squared minus b squared. So I'm still going to be ending up with square root of a squared minus b squared, of which is of no use. Okay, so for a case like this, we are still multiplying by everything here. Okay, so in a case like this, we are still going to multiply by the square root of a plus b divided by the square root of a plus b, simply because, remember, the law says when you are multiplying two numbers such that everything under the square root they are the same, we simply pick one inside. So if we multiply these two guys, they are exactly the same, we are going to pick a plus b inside of it. So the numerator becomes what now? Square root of a plus b, okay, divided by what now? A plus b. Okay, so that is how problems of rationalization are being tackled in Surds. Okay, we are then going to be solving a few problems on the board that are still relating to Surds and its laws. Okay, so here are some questions on the board. We have 8 questions on Surds. Now these are past questions from WAEC, NECO and JAMB as well. Okay, I just did not write the years. Okay, now the first question here says simplify 5 root 12 minus 4 root 75 plus 3 root 48. Now for a problem like this, here's how you solve questions on Surd. Okay, for something like this, what you want to do is, since all of them are having square roots, we are going to try and reduce all the numbers, okay, to see if they can have a common square root, like making this one have square root of 2, square root of 2, square root of 2, or square root of 3, square root of 3, square root of 3, depending on the numbers that are given. Okay, so I'm going to start a solution. So for the first question, we're having 5 root 12 minus 4 root 75 plus 3 root 48. Okay, now here's what we're having. Looking at these numbers, I might want to reduce this one to 2. Okay, so I can write it as, let's say, 6 times 2. But if I come here and check, I know this is an odd number, so it cannot be divided by 2, which means 2 probably not work, even when this one can be divided by 2. Okay, I need to look for a number that is common to all the numbers inside of the square root. Now let's try 3. 3 is common to 12, right? That will be 4 times. 3 is common to 75. That will be like, how many times? That's 25, right? And then 3 is common to 48 as well. That will be like 16, isn't it? Now if we choose to divide 2 by 3, it means we can write all these numbers in terms of what now? 3. So we're going to write 5 square root of 3 into 12 is 4. So it means 12 can be written as 4 times 3, right? 4 times 3 will give you 12, right? Minus 4 square root of 3 into 75. We divided it just now, so it was 25, right? So it means this can be written as 25 times 3. Okay, plus 3 root 3 into 48. We divided it again, we said it was 16. So this can be written as 16 times 3. Okay, so from here we simplify. Remember the laws of Surd. If you are multiplying two numbers inside square root, it means you can invert it. Okay, so this can be written as 5 times the square root of 4 times the square root of 3, right? You can break it down simply because I'll remind you of the law. Root a times root b is equal to root a times b, which means for having root a times b, we can take it back. Root a times root b, that's what we did here. Okay, minus 4 root 25 times root 3, that's what we did again. Let me put it in brackets just so I don't confuse you guys. Okay, plus 3 root 16 times root 3. So you see, it is getting simpler, okay, as we go. Now square root of 4 is 2. 2 times 5 is 10. Okay, so I'm going to get 10 times square root of 3, right? Minus square root of 25 is 5. 5 times 4 is 20. So I'm going to get 20 times the square root of 3. And then plus square root of 16 is 4. 4 times 3 is 12. So I'm going to get 12 times the square root of 3. Okay, so now let's simplify. 10 times root 3 is 10 root 3. Okay, minus 20 times root 3 is 20 root 3. 12 times root 3 is what now? 12 root 3. Okay, so from here, let's do the math. How we are going to solve this aspect is very easy. Okay, Now we're having 10 root 3 minus 20 root 3 plus 12 root 3. Here is how to do a problem like this, okay? Now let's imagine root 3. Since root 3 will come out to them, let's imagine root 3, let's call it x, or let's call it cows, okay? Let's say root 3 stands for a cow. So we're having 12 cow here, minus 20 cow here, and 10 cows here, okay? So I'm going to say 10 cows minus 20 cows. That's what now? Minus 10 cows, right? Minus 10 cows plus 12 cows. What are you going to get? I'm going to get 2 cows, okay? Remember, cow represents root 3. So we can just come here and write what now? 2 root 3. Please make sure you don't write cow, okay? Try not to write 2 cows so you don't go and say the answer is not in the option, probably in an examination, okay? Now, we'll be having 10, or we have rather 2 root 3 after doing this, okay? So the basic knowledge behind it is just to assume these root numbers to be something common to all of them, okay? That is 10 root 3 minus 20 root 3, that is minus 10 root 3 plus 12 root 3, that is what now? 2 root 3, okay? So that is the answer to the question asked in the examination. Now the question 2 says simplify 3 root 18 minus 16 over root 2 plus root 50. So for question 2, it says, maybe I should be able to solve question 2 over here. Question 2 says 3 root 18 minus 16 over root 2 plus root 50. What then are we going to get? Now, how then do we simplify this? Remember, you have to remove this guy from the denominator. That is very important, okay? And then break these numbers down. Now, so say something is common, let's first remove this one from the denominator. Now, to remove it from the denominator, remember we have to multiply the top and bottom by the denominator, right? I explained under rationalization. So if you forgot, you might want to rewind the video a little bit to watch it. So I'm going to get 3 square root of 18 minus 16 over root 2 times root 2 over root 2. Okay, we are doing this because we want to rationalize this guy. Plus root 50. Okay, so I'm going to get 3 root 18 minus, now 16 times root 2 is 16 root 2 divided by root 2 times root 2, that is what now? 2 plus root 50. Okay, so I'm going to get 3 root 18. 2 here is 1, 2 here is 8, so we have minus 8 root 2 plus 50. Now, since we've simplified all of them, remember the same trick we used there again. I want to look for a number we used to divide that will make it common to all of them. Now, 2 is obviously the number, because if I put 2 in here, 2 into 18 is what now? 9. So I can write this as 9 times 2. I can write 2 as what now? I can leave 2 like that simply because there's nothing I can use to reduce it. Well, why for 50? I can write it as 25 times 2. Okay, so here's what I'm talking about. Now, the only way for you to think about these things the way I'm thinking about it so far is by solving countless number of problems. When you solve 100 questions on solve, trust me, when you encounter problems like this, you don't have to start thinking, what number can I use? Okay, it will just come automatically, simply because you solve lots of problems, okay, over months or weeks or years, as long as it takes for you to solve a lot of problems in maths. Okay, so you can write this as 3 times the square root of 9 times 2 minus 8 root 2 plus square root of 25 times 2. Now, I'm going to be skipping steps simply because I've explained these things over there. Okay, now square root of 9 is what now? 3 times 3 is 9, so I'm going to be left with 9 times, remember there's a square root affecting the 2 as well, 9 times root 2, or let's just write it as 9 root 2. Okay, so I have 9 root 2, which is same as 9 times root 2. Now this remains 8 root 2, and then we'll have plus square root of 25 is 5, so we'll be left with 5 times the square root of 2, which is 5 root 2. Now let's do the math. We'll arrive at the same place again. So 9 root 2 minus 8 root 2 is 1 root 2. 1 root 2 plus 5 root 2, that's 6 root 2. So it means our answer to this question is 6 root 2. We can't simplify this further, so we'll leave this as the answer. Okay, that is how problems like this are being tackled. It is very easy. Now the next question on the board is question 3. Okay, now question 3 wants us to solve for, it says the square of 3 minus root 2 is, which means if we put 3 minus root 2 in brackets and then square it, what are we going to get? That is what it's asking us. So for question 3, it's saying the square of 3 minus root 2, that is, let's square this in brackets. Now by squaring it in brackets means we are going to multiply everything here by itself. Okay, so we are going to have 3 minus root 2 rather multiplying 3 minus root 2. Okay, don't make the mistake of putting a plus here thinking it's difference of 2 squared. Okay, it doesn't work that way. Okay, what we're having here is this one multiplying by itself. Okay, so from here we're going to do the math. The first one multiplies the first one. 3 times 3, that is 9. 3 times minus root 2, that is minus 3 root 2. Now minus root 2 times 3, that is minus 3 root 2 again. Minus times minus is plus. Root 2 times root 2 from the laws of surds. Remember, root a times root a. Okay, remember, root a times root a is equal to a. Okay, so root 2 times root 2 give you what now? 2. From here we cannot simplify. So we're going to have, now these are just whole numbers. 9 times 2, 9 plus 2 rather is 11. Okay, and minus root 2, minus 3 root 2 rather, minus 3 root 2, that will give you minus 6 root 2. So you see, these problems are very easy to tackle. Okay, all you have to do is get into the process. Okay, get into the maths while you're solving. Okay, and solve multiple examples so that as you are solving them, as time goes on, you get used to the numbers that you can bring out from these roots. Okay, now the next question here is question 4. It says simplify 5 root 5 plus root 2 times root 5 minus, this one is simply difference of 2 squares. Remember, I explained already. Difference of 2 squared is mixed for having a plus b times a minus b is going to be equal to a squared minus b squared. So that is exactly what we're having here. Okay, so for question 4, we're going to be having, or we're given rather, the square root of 5 plus 2 times the square root of 5 again minus 2. Now this multiplies this, that gives you 5. Root 5 times minus 2, that is minus 2 root 5. 2 times root 5, that is plus 2 root 5. 2 times minus 2, that is what now? Minus 4. Okay, so 5 plus 4 is 9. Minus root 5, minus 2 root 5 plus 2 root 5, that's 0. Okay, so we're simply left with what now? 9. So you see, these questions are very easy. All you have to do is solve them, and within seconds you are done. Okay, now here is number 5. It says simplify 1 over 2 minus root 3 minus 1 over 2 plus root 3. Okay, so for number 5, it says simplify 1 over 2 minus root 3 minus 1 over 2 plus root 3. Now some questions might take you time to solve, but definitely if you are good with it, it's going to take you less time, okay, on average. So let's solve this one. Now for a problem like this, you notice that we're not having multiplication here, neither are we having division. So it means we have to take an LCM. Okay, now for the LCM, you just have to multiply the denominator. This means we're going to be having 2 minus root 3 times 2 plus root 3. You see it's even making the question easy for us, because at the bottom we're already having difference of 2 squared, something we did just now. So I'm going to skip some of these steps and go directly to what we are having. Okay, and also in number 4, you notice that we could have used difference of 2 squared, okay, to get the same answer. So if I pick this one instead, I'm going to be having the square root, okay, let me do it somewhere. Okay, we're going to be having the square root of 5 all squared minus 2 squared, right? Square root of 5, square cancels this one, so we're having what now? 5, right? And then 2 squared is what? 4. So 5 minus 4, that should be 1. We have to, now here is the mistake. 5 minus 4 is 1, not 9. Okay, here is the mistake. Thank God I decided to cross check using difference of 2 squared. Okay, so please avoid such mistakes. Okay, avoid such mistakes. 5 minus 4 is 1, and all these other ones cancel out to give you 0. Okay, so our answer is actually 1. You see, we are always going to get the same answer no matter the procedure we are using. Okay, so avoid mistakes like that. Now 2 minus root 3 into this one gives you 2 plus root 3 times 1, so you have 2 plus root 3. Okay, this is the normal LCM I'm doing, so you might want to do it yourself. Okay, minus, I'm putting it in bracket because it's the minus. Okay, now 2 plus root 3 cancel this one, so I left with 2 minus root 3, so we have 2 minus root 3. Okay, so from here we're going to have, open the top brackets, we're going to have 2 plus root 3 minus times 2, that's minus 2, minus times minus, you see what I'm saying? We're going to get plus root 3 divided by, now from this bottom we're having difference of 2 squared, the same rule we applied here. So I'm going to pick the negative one and square each of them. So I'm going to have 2 squared minus root 3 all squared. Okay, so from there, let's finish it up. From the top, 2 minus 2, that's 0. Root 3 plus root 3, that's 2 root 3. Okay, divided by 2 squared is what? 4. Minus square cancels square root, so I left what now? 3. So this is equal to 2 root 3 divided by 4 minus 3 is 1. So this is 2 root 3. And that is how a problem like this is being tackled Okay, all you have to do is practice more exercise like I will always say. Now we've succeeded in solving question 5. Let's go to question 6. Question 6 says simplify 8 minus root 2. You can see it on the board. That is what question 6 wants us to do. So I'm going to come here and write question 6. I don't know if this space will be enough, but I'm still going to start here anyway. It says simplify the square root of 8 minus the square root of 2 divided by the square root of 8 plus the square root of 2. Now for this, remember I explained before, when we're having such like this, we are going to rationalize. That is, multiply the top and bottom by the conjugate of the denominator. What is the conjugate of the denominator? The negative one of this. So I'm going to multiply by the square root of 8 minus the square root of 2 divided by the square root of 8 minus the square root of 2. Okay, from here we're going to do the math. That is going to give us the square root of 8 minus the square root of 2 times the square root of 8 minus the square root of 2. This marker is quite faint. Let me. Okay, now let's multiply the bottom. We're going to get square root of 8 plus square root of 2 times square root of 8 minus square root of 2. Okay, that's what we're going to have. Now for the top, we're just having a bracket multiplying itself because it's the same thing on top. Okay, so for that, we can just pick it as, or let's do it directly. Root 8 times root 8 is 8. Root 8 times minus root 2, that's 8 times 2, which is 16. Okay, so you have minus root 16 minus root 2 times root 8, that is another minus root 16 minus root 2 times minus root 2, that is what now? Minus times minus is plus. Root 2 times root 2 is 2, so you have plus 2 divided by, now for the bottom we're having difference of 2 squared. Okay, so I'm going to pick negative 1 as squares, so that is square root of 8 all squared minus square root of 2 all squared. Okay, so from there we're going to have from the top 8 plus 2, that is 10, minus root 16 minus root 16, that is minus 2 root 16 divided by square cancel square root, so we're having 8 minus square cancel square root, so we're having what now? 2. Now square root of 16 is what? 4. 4 times 2 is 8, so I have 10 minus 8 at the top divided by 8 minus 2, that is what now? 6. So this is equal to 2 over 6, which simplifies to 1 over 3. Okay, so the answer to this question is 1 over 3. It might take time, but as far as you're on the right track, nothing is going to be wrong. Okay, now question 7 says 2 minus 1 over 2 2 minus 1 over root 2 minus 1. I'm going to take off this part. This should be enough for us to solve both questions. So for number 7, the question says 2 minus 1 over root 2 minus 1. Okay, we're going to get, we can write this as over 1, so we'll take LCM. LCM of 1 and root 2 minus 1 is root 2 minus 1. Okay, 1 into this is exactly this times 2, so we're going to have 2 in brackets root 2 minus 1 minus this into this cancels as times what now? 1. So from here we're going to be left with 2 times root 2 is 2 root 2. 2 times minus 1 is minus 2 minus 1 divided by root 2 minus 1. Now let's simplify. Okay, what can we simplify here? Minus 2 minus 1 is minus 3, and then plus 2 root 2 divided by root 2 minus 1. Now the next thing we want to do here is rationalize. Once we rationalize, we're done. Okay, we would have ended here, but because there's a surd here, we have to rationalize. Now to rationalize, we are going to multiply by the conjugate of the denominator. Okay, so we're going to have at the top minus 3 plus 2 root 2 divided by root 2 minus 1, multiplying by the conjugate. What's the conjugate of root 2 minus 1? That is root 2 plus 1 over root 2 plus 1. Okay, now multiplying the top, it means we are going to have minus 3 plus 2 root 2 times root 2 plus 1 divided by root 2 minus 1 times root 2 plus 1. Okay, so then we're going to be having, now minus 3 times root 2 is minus 3 root 2. Minus 3 times 1 is minus 3. Root 2 root 2 times root 2. Root 2 times root 2, that's 2 times 2, that will give you 4. So you have plus 4. 2 root 2 times 1, that is what now? Plus 2 root 2 divided by the denominator, we're having difference of 2 squared. Okay, so I'm going to square each of them. That is root 2 squared minus what now? 1 squared. So from here we're going to have from the numerator minus 3 root 2 plus 2 root 2. That will give you 2 minus 3, that's minus 1. So you have minus root 2. Okay. And then 4 minus 3, that is 1. Divided by, from the bottom, square cancel square root, so we're left with 2 minus 1 squared is what now? 1. So this is minus root 2 minus 1 divided by 2 minus 1, that is 1. Okay. So 1 into this guy simplifies it. We're going to get minus root 2 minus 1 as our answer. Okay. Now I just hope there's no mistake because I can't review it. Okay. I can't review it because there are other questions we're going to tackle. So, or let's just go through it in general to make sure our answers are on track. Okay. So having 2 minus 1 over 2 root 2 minus 1. Okay, we're going to have root 2 minus 1 as the multiply minus 1. You have 2 root 2 minus 2 minus 1 root 2 minus 1. You can review it yourself. Okay, I'm just going to be quick with it. So you have root 2 minus 1 minus this guy, that is okay. Then we rationalize from here. Root 2 minus 1 multiply the top and bottom by the conjugate. This one gives us difference of 2 square, which is obviously 2 minus 1, which is at the end. So the bottom is good to go. Now for the top, minus 3 times root 2. Okay. I brought them together. Minus 3 times root 2 is minus 3 root 2. Minus 3 times 1 is minus 3. Root 2 times this one. This one gives you 2 times this 4. Okay, so we are good to go. Minus 3 root 2, that's minus root 2. This one gives you minus 3 plus 1. Minus 3 plus 4. This is supposed to be 1. Okay? Like I said, we have to review it just to make sure there is no mistake. So 4 minus 3 is 1. Okay, so this should be plus, this should be plus, and this should be plus. So we can write our final answer as 1 minus root 2. Okay, good to go. Okay, now you might not have enough time to review questions like this in an examination, so I advise you to at least go smoothly, try to be fast but not too fast so you don't make mistakes like these ones. Okay, you see, after solving in the end, just a little time might make your answer different. Okay, so that is the answer. Now for the last question, question 8, it says simplify 1 over root 2 in brackets. You can see the whole question there. Okay, I'm still going to take out this part so that I can solve that one. I'll prefer to use this same part simply because I think it has a bigger space. Okay, now for question 8, it says 1 over root 2 in brackets 1 over root 3 plus root 2 minus 1 divided by root 3 minus root 2. Okay, so I'm going to have 1 over root 2. Now let's simplify the bracket first. Okay, let's simplify. Oh, I think if we open the bracket using this 1 over root 2 to make it easier, right? I just want to use the shortest possible method available. Okay, so if I use this to multiply, I think it's to make it easier. So 1 over root 2 multiplies the bracket. So we're going to have 1 over root 2 in brackets root 3 plus root 2. Okay, 1 times 1 is 1. Root 2 times everything is what I have in here. Minus 1 over 1 times 1 is 1. Root 2 times everything I have in here is root 2 in brackets root 3 minus root 2. Okay, so I'm going to have 1 divided by root 2 times root 3 is root 6. Root 2 times root 2 is what now? 2 from the laws of Surds. Minus 1 over root 2 times root 3 is root 6. Okay, root 2 times this one, that will give you minus 2, right? So from here we are having just two fractions that are going to simplify. So LCM is multiplying them. That is root 6 plus 2 times root 6 minus 2. So this one into this one gives you root 6 minus 2 times up. That's root 6 minus 2 minus in bracket. Anytime there's a minus, I like putting it in brackets because minus can change whatever is inside. Okay, root 6 minus 2 cancels out this one. So I left with root 6 plus 2 times 1. That's root 6 plus 2. Okay, so I'm going to be left with opening the top bracket. We have root 6 minus 2 minus root 6 minus 2. Minus times this is minus root 6. Minus times plus 2, that's minus 2. Divided by difference of 2 squared at the bottom. So I'm going to get root 6 all squared minus 2 squared. So from here, we're going to have Root 6 minus root 6, that's 0. Minus 2 minus 2, that's what now? Minus 4 divided by square cancel square, so I left what now? 6 minus 2 squared is what now? 4. So this is minus 4 divided by 2, which is equal to minus 2. So our final answer to this question or problem is minus 2. Now, we succeeded in solving these problems on Surds, on past questions. Now, I selectively pick these ones so that I can touch various aspects relating to different questions that you could find in Surds. Now, you can solve more problems by yourself. Okay, that is how questions like this are being tackled. If you're new to this channel, don't forget to subscribe. Share with your friends so your friends can learn as well. If you're preparing for any external exam, JAMB, WAEC, NECO, and so on and so forth. Okay, even if you want to make a revision based on the fact that you've done math so far, this is the right place to be in. Now, don't forget to click on the notification bell so that when a new video is being uploaded, you'll be one of the first few persons that will get notified about it. Okay, don't forget to subscribe because you can't click on the notification bell without subscribing. Okay, see you in the next video. Bye.